Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about area, volume and measurement and differentiation. Now the question I've chosen to go through here is 2019 paper 1 question 9. In this question we're given a Norman window which consists of a rectangle and a semicircle on top of it. And we're given this distance is labelled as x and this distance is labelled as y. We're asked to find the perimeter of the entire Norman window in terms of x, y and pi. We're asked to symbolize this as p. So it's relatively straightforward here because we've been given as much information as we need. I know that the distance from here to here is y, so clearly the opposite one, the distance from here to here, will also be y. If this distance is x, I can say that this distance is x as well. So straight away I can say that that's y, 2x and y, so clearly there's two y's and two x's. The perimeter of the rectangular bit, the three sides of the rectangle that make up the perimeter, is 2x plus 2y. Slightly more difficult to get the perimeter of the semicircle. According to your log tables, the circumference of a circle is given as the formula L is equal to 2 pi r, where L represents the circumference of a circle. Now obviously we're not dealing with a full circle, we're dealing with half of a circle. So instead of the circumference being 2 pi r, it's going to be half of that. Half of 2 pi r is just pi r. So in other words, the circumference or the perimeter of a semicircle is pi multiplied by r, where r represents the radius. Now clearly the radius of this semicircle, if we just work our way down, it's x as well. So the perimeter of the semicircle is pi by r, or in other words pi by x. So that's your final answer for the first part. The perimeter is 2x plus 2y plus pi x. Now you got the full marks for that in that case, but just to be safe, since it did mention meters in the question, I would always indicate if you're dealing with a distance that this is in meters. So you could say it's 2x meters, 2y meters plus pi x meters, or you could just label it as that, where the whole thing is actually in meters. In the second part of this question, we're told that the perimeter of a specific Norman window is 12 meters. And we're asked to prove that in that case, y is equal to, and you need to write y in this form. In the previous part of the question, we worked out the perimeter is equal to 2x plus 2y plus pi x. Now clearly if we manipulate this, we need to sub in the perimeter being 12, and if we manipulate it, we should be able to get to that point. So I've been told the perimeter is 12, so that's the first thing we should do. Just rewrite it as 12 is equal to 2x plus 2y plus pi x. And now all I want to do is isolate my y, get y on its own. So I'm going to bring the other two terms on the right hand side over to the left. If I do that, I can say that 12 minus 2x minus pi x is equal to 2y. Now clearly I want to get y on its own, so I'm going to divide everything by 2. If I divide everything by 2, the right hand side just becomes y, and the left hand side stays the same, it's all over 2. Now you should obviously, at this stage, you want to look at the way they asked you to leave your answer. All they've done here is they've factorized x out of the last two terms, which is exactly what I can do here. They've factorized out a minus and they've factorized out an x. So what I want to do is first, if we factorize out a minus, it becomes 2 plus pi, and I can leave the x out here. Now all I've done there is I've factorized out the minus and I've factorized out the x. Usually we'd put the minus and the x in front of the bracket, but since they left it in that form in the exam, we're better off to do it exactly the way they left it. So I can say that y is equal to this. And that's what I was asked to prove, so that's my final answer. Okay, in B part 1 we're given the following table. We're given two values for x, which is 0 and 12 over 2 plus pi, and then we're asked to find two corresponding values for y. And y, we're using the same thing that we derived in A part 2. So obviously this just means we got two values for x, we're going to sub it into the function for y and find the two different y values. Now I've already done that here. If I sub in x equals 0 into my y, just instead of an x I sub in a 0 and my value ends up as 6, which means my first coordinate is the coordinate 0, 6. And what I did in the second one is instead of an x we subbed in 12 over 2 plus pi, and if you sub that in it actually works out as 0. So my second coordinate is 12 over 2 plus pi, 0. And now we're going to use these two coordinates to complete B part 2 and draw a graph. Okay, in B part 2 we're asked to draw the graph basically of the two coordinates we got in B part 1. The two coordinates were 0, 6 and 12 over 2 plus pi 0. Now obviously it's hard to plot that, so I plugged this into my calculator and realized that that actually corresponds to 2.33. So we're plotting the point 2.330. Now once we've got two coordinates and we're drawing a line, that's all we need. So 2 points on a line, we can draw the line. You'll notice here that I've drawn a rough sketch of the graph you've been given. What I would do is I'd plot my point 0,6 and label it as 0,6. I'd plot my point, which is 2.330, and label it as what was given, or in other words, label it as 12 over 2 plus pi 0. Now when you're drawing a line, you have to use a ruler. So make sure you're using a ruler to join up the 2 points with each other. And that's all we need to do to get the marks for this part. Okay, so in B part 3, we're asked to find the slope of the graph and interpret it in the context of the question. Now, since we know two coordinates, I've labelled them as x1, y1 and x2, y2. The easiest way to get the slope is to use your formula from your log tables, y2 minus y1 over x2 minus x1. I just plugged in my values and my slope works out as minus 2.57. Now, you should realise that when you're getting the slope, you're comparing the difference between the y values to the difference between the x values. And in this case, the x values refer to the radius of the semicircle and the y values refer to the height of the rectangle. So I can interpret my minus 2.57 by saying that for every 1 meter rise in the radius of the semicircle, the height of the rectangle falls by 2.57 meters. So that's what the minus 2.57 represents, and that's what I need to get the full marks for my interpretation. Okay, so for C part 1, we're gone back to the original diagram. And we're asked to find the area of the Norman window and leave it in the form 24x minus pi plus 4 times x squared all divided by 2. So clearly we're dealing with two relatively basic shapes here. The Norman window is made up of a rectangle and a semicircle. In order to get the area of a rectangle, it's just the length multiplied by the width. So that's what I'm going to do to get the area of my rectangle. And in order to get the area of a semicircle, well, according to the log tables, the area of a circle is pi r squared. So clearly a semicircle is going to be a half pi r squared. It's going to be a half multiplied by pi r squared. But if we want to make this a bit neater, rather than writing that as a half multiplied by pi r squared, we can just call it pi r squared over 2, or pi r squared divided by 2. Now I need to get this answer in terms of x and pi. So the first thing I'm going to have to do is use the variables involved in the diagram. The area of the rectangle is the length multiplied by the width. Clearly the length of this entire distance will be 2x, so I could say the area of the rectangle is 2x multiplied by the width, which is y, or in other words just 2xy. And the radius of the semicircle is the distance from here to here. It's obviously the same as x, so in this case the radius of the semicircle is just x, so I can write the area of the semicircle is pi x squared divided by 2. My problem at this stage is that I want my answer in terms of pi and x. So I need to get rid of my y. But they've mentioned again, this bit that I've highlighted up here, they've mentioned again that y can be written as 12 minus 2 plus pi times x over 2. So all I need to do in my next line is just substitution. So I'm going to write this as 2x multiplied by, and instead of y, I'm going to plug this in, multiplied by 12 minus 2 plus pi times x all divided by 2, and then I'm just going to add on my plus pi x squared over 2 because there's nothing I can do with that. Now this is the area of my Norman window in terms of x and pi. So after this now I just need to manipulate it as much as I can so that I can get to this answer. So in a question like this, I think you want to take it step by step. Probably the best thing to do now is you need to realize that you're dealing with two fractions and you're adding them together. If you're adding or subtracting fractions, the easiest thing to do is always to get a common denominator. In this case, it's very straightforward. They're both over 2, so I can actually just write it as one fraction. I can put them all over 2, and I don't really need to manipulate the top line at all. So I can rewrite the top line as just 2x, and I'll keep this bracket 12. Now what I'm going to do here is I'm going to multiply this out. I got minus by x, so I'm just going to rewrite this in another form, minus x times 2 plus pi. It'll just be easier for us to multiply that out in the next line. So now at least I have them all in the same fraction, and now all I'm going to do is multiply this out and try and get to this stage. Okay, so all I need to do now is step by step, this is where we are, this is where we need to go. So at each line, try and simplify it down. So what I'm going to do next is I'm going to multiply minus x by that bracket. So more or less, the vast majority of it stays the same. It's still 2x times 12, and then minus x by 2 gives me minus 2x. Minus x by pi gives me minus pi x. And then at the end, I still have a plus pi x squared. And the whole thing is over 2. Clearly, my best bet now is on the next line, multiply 2x by these three terms. 2x by 12 is 24x. 2x by minus 2x is minus 4x squared. 2x by minus pi x is minus 2 pi x squared. And my last term is plus pi x squared. And then I just divide it all by 2. Now what you need to notice here is that the last two terms of the numerator are like terms. I've got minus 2 pi x squared plus pi x squared, so I can clearly add those together. My first two terms will stay the same, 24x minus 4x squared, but here I have minus 2 pi x squared plus 1 pi x squared gives me minus 1 pi x squared. And that's all divided by 2. Now we just need to manipulate it so we get to our answer. All they've done here is, you need to notice that what's common to the last two terms on the top is minus x squared. So we factorize out a minus and we factorize out an x squared. And I can rewrite this as 24x minus, let's say we factorize out minus x squared. Minus x squared out of the first term gives me 4. Minus x squared out of the second term gives me plus pi. But we should leave it exactly the same way as they have it in the exam. So in the exam, they put the x squared at the end of the bracket. So rather than putting the x squared in front of it, I'm actually going to move it to there. I've factorized out minus x squared. I'm just writing it in a different order. And then the whole thing is still over 2. Now, just to be safe, we are dealing with meters here. It told me that x was in meters, that y was in meters, and that the perimeter is 12 meters. So just to be safe, I'd always add in a meters at the end, since we are dealing with units. Okay, the next part, C part 2, it asks me to find the derivative of a of x. Now, previously we've worked out a of x in this form, but that's going to be incredibly messy to try and differentiate it like that. So all I've done so far here is I've just simplified it. So what I did first was I multiplied x squared minus by x squared by pi gives me minus pi x squared, minus by x squared by 4 gives me minus 4x squared. And then rather than writing it as one continuous fraction, I've written it as 3 different fractions. I just have it as 24x over 2 minus pi x squared over 2 and minus 4x squared over 2. That makes life way easier because now 2 into 24, that just becomes 12x. Instead of writing this as pi x squared over 2, it's easier to think of it as minus a half. Oh, I forgot my pi there. It's easier to think of this as minus a half pi x squared, and 2 into 4 gives me minus 2. And at this stage, I haven't differentiated at all. All I've done is simplified it down, but it's going to be a lot easier for me to differentiate now. Because clearly the derivative, this is 12x to the power of 1. The 1 comes in front, and it just becomes 12x to the power of 0. Or in other words, the derivative of 12x is just 12. I have to get the derivative of minus a half pi x squared. Well, okay, take the minus down, and then the power comes in front. So 2 multiplied by a half pi will just give me 1 pi, because the 2 multiplied by a half is just 1. So that just works out as pi x, and it becomes x to the power of 1, because your power decreases by 1. The derivative of minus 2x squared, the 2 comes in front, and just becomes minus 4x. So that's all. The differentiation step was actually quite straightforward if you simplify down as much as possible. So your derivative there, it just works out as this. Okay, in C part 3, we're asked to find the relationship between x and y when the area of the window is at its maximum. So in this case, you should realize that the minute they say maximum, they're talking about a turning point. And to identify the turning point of a graph, it means that the slope is equal to 0. Or in other words, it means that the first derivative is equal to 0. So in order to identify the maximum point, the maximum when the value of x for the maximum area, what we need to do is we need to let the first derivative equal to 0. So that's what we did. In C part 2, we worked out the derivative is 12 minus pi x minus 4x. So we let it equal to 0. Now I've got one equation, one unknown, so that means I can find the value of x. All I did first was I brought the 12 across and it became negative. Then the issue here is that there's two different x's, so you have to factorize out your x, and you're left with minus pi minus 4. And then to get x on its own, you just divide both sides by the minus pi minus 4, and x works out as minus 12 over minus pi minus 4. You plug it into your calculator, and x is 1.68. That's not the question now, but now I know that when x is 1.68, that's when we achieve the maximum area of the Norman window. Now I need to find the corresponding value of y, and hopefully I'll identify some kind of a relationship between the two. So remember, in C part 1, I know what y is in terms of x, which means that once I know x, I can now go back and find the value of y. So now that I know the maximum exists when x is equal to 1.68, that means instead of an x now, I'm just going to sub in 1.68. Plug all that into my calculator, and your y value actually works out as 1.68 as well, which means that at the maximum, the x value and the y value are the same. So it asked you to describe the relationship, so now with my conclusion I could just say when the area is at its maximum, the value of x equals the value of y, or in other words 1.68, they're both 1.68 meters. So I hope all of that video makes sense. If there's anything you're unsure of there, or you'd like me to clarify something, then just send me an email or let me know in class, and I'll try and explain it a little bit differently.